Okay, so now we're actually starting to build a circuit and we're going to analyze a circuit in depth today. So to begin this, we're in the same simulation that we were in last week, or a slightly different link, but it looks very, very similar. But we're going to need a battery. That's going to be what provides some electrical potential or some voltage into our system. So again, voltage is just a measure of the difference in electrical potential, usually if we're using a battery, between those two different terminals within our battery. We have current, we'll have electrons flowing through our circuit. We have resistance as provided by this light bulb, so that's what slows down the electrons slightly as they flow throughout this circuit. And that will show the most simple circuit that we can build. One battery, one energy source connected to one output, one sort of electrical load in the form of this light bulb. Now, what you all are trying to do is actually measure the current and see what happens to the current or the rate of these electrons flow as they flow through the circuit as we change the resistance in this light bulb. And the way that you can do that is if I click on values first, it shows me what the voltage of this battery is. It also shows me what the resistance of this light bulb is. But it doesn't show anything about the current, again, or the rate at which these electrons flow through the circuit. So to measure that, I'm going to bring out what's called an ammeter. Ammeter comes from the fact that the standard unit for current is amperes or amps. So we have A as our standard unit, or our abbreviated unit for current. Now to measure this, it's really easy. All I do is I take this sort of target looking thing and I put it over any part of our circuit, right? And so I've sort of given away an answer here. But let's say I want to change my voltage. Let's decrease the voltage down to 7. And maybe I want to also turn down my resistance to 4. And now let's see what that current is. So 1.75 amperes or 1.75 amps is the current in this system as is. And for your work today, you're first going to use those default numbers, which if you take a look back, I might have just accidentally given the answer to. But then you'll also see what happens if with the default 9-volt battery, what happens as you increase this resistance to 20, 30, and 40 ohms, and you'll measure the current with this ammeter there. Now, one important thing to note, and you can investigate this on your own too, I can put this at just about any different place in the circuit, and I'm getting the same 1.75 amperes or 1.75 amps no matter where I go. Now, in the future, that might not always be the case, but you can see if that's the case in the circuit that you build. For now, it looks like it should be the same throughout the whole circuit. Again, that might not always be the case, but that's all you need to do today is vary this resistance to 10, 20, 30, and 40 ohms with the standard 9-volt battery. So you will have not this 7-volt battery that I have, but the 9-volt battery there.